Good day, everyone. Today we will be presenting our video lab experiment entitled Pearl Plate Capacitors by Einstein Group 26 of STEM 129. So without further ado, here is our presentation.
Using the PhET simulator, we conducted an experiment in our laboratory so that we continue to observe and review and complete the results of each trial are listed. We used to have constant distance between charges to fully comprehend what was going on, as well as multiple trials of constant same charges to observe. The element has the biggest impact on the final free Coulomb's law state that the force between 2 points would be proportional to the magnitudes of 2 points charge. When the distance between the charges is taken into account, the opposite is true. The rule of the Coulombs allow one to determine which way the electrical field is leaning. In our procedure, we open again the PhET simulator, then go to the capacitor lab. Then we choose the light bulb sign. After we choose it, open it, then you see the parallel plate capacitor, then use the voltmeter to test the voltage or different potential. Set the voltage in the capacitor, then you can change the voltage battery either down or up. Then there are two values needed in record: capacitance and top plate change, so that you can perform the experiments.
Hello, my name is Christian Gerentilio, and this is our laboratory experiment number 2 in physics, and I'll be showcasing on how the PhET simulator works and what are the values that we recorded for our experiment. For table A, we maintained the voltage at 0.45 volts and the distance of separation at 3.6. So our first value we decided on our area was 130, and the charge and capacitance was at 0.14 and 0.32. The next value we decided was 170 for our area, and the charge was 0.19 and the capacitance at 0.42. Next, we changed the area at 210, and the charge is at 0.23 and the capacitance at 0.52. The next value for our area is 280, and the charge and capacitance at a value of 0.31 and 0.69. And for the last value for table A was 330 for our area, and the charge and capacitance at 0.37 and 0.81. For table B, we maintain the voltage value at 1.2 volts and the area of the plate at 360. So we decided that the first value for table B in the distance of separation is at 2.6, and the value of the charge and capacitance is at 1.47 and 1.23. The next value for the distance is at 3.2, and the charge and capacitance is at 1.20 and 1.00. Next, we decided the distance at 4.8, and the charge and capacitance is at a value of 0.80 and 0.66. The next value for our distance is at 7.4, and the value for our charge and capacitance is at 0.52 and 0.50 and 0.43. And for the last value for table B was at 9.2 for the distance and the charge and separation at 0.42 and 0.35. So after finding the data using Fetch Simulator, we then documented all the data for our table in Word document. So this is what it would look like after we have documented all the data that we have compiled from Fetch Simulator.
Parallel plate capacitors are made by arranging two plates of insulating material parallel to each other for distance in between the plates. Voltage applied to the capacitor is stored as energy, and when high enough voltage is applied, dielectric breakdown occurs, where the insulating material suddenly becomes an electrical conductor. Table A, since the voltage and distance is set constant, when the area of the plate is set at 130 mm squared, the charge of the plate is sufficient enough to light up the light bulb, but only very quickly. As the area of the plate increases the duration of the light bulb. In Table B, the closer the plates are, the longer the duration of the light in the light bulb, while if the plates are further away, the duration of the light is shorter. In Table A, the distance of separation, 3.60 mm, and the voltage, 0.45 volts, is held constant. Comparing the values of charge in the plate and the value of capacitance between the largest area set, 330 mm squared with 0.37 pC and 0.81 pF, to the smallest area set, 130 mm squared with 0.14 pC and 0.32 pF, the area of the plate is directly proportional to the charge in the plate and the value of capacitance. In Table B, the area of plate, 360 mm squared, and the voltage, 1.2 volts, is held constant. Comparing the values of charge on the plate and the value of capacitance between the farthest distance of separation, 9.2 mm with 0.42 pC and 0.35 pF, and the closest distance of separation, 2.6 mm with 1.47 pC and 1.23 pF, we can notice how the distance of separation is inversely proportional to the charge in the plate and the value of capacitance.
To conclude the experiment, observations, analysis, and computations done were similar, but there was a difference in value of each charge. It is because being inversely proportional to the charge, we can see that the increasing and decreasing the separation distance of two capacitors will also affect the value of the capacitance. So, therefore, decreasing D will increase the C and vice versa. So that the values of each charge will be determined.